Okay, next is water quality. How good a water do we have is going to have an effect on how that sprinkler performs. If we have a lot of debris in that water, we can get things like plug nozzles, and that's really where we're headed on water quality as far as performance is concerned, or buildup of minerals in the nozzle if it's high mineralization in the water. We can actually reduce the size of the orifice due to mineralization, clogging. Chunks can get wedged in the nozzle themselves and actually block the nozzles. Or we can have the opposite effect, and that is if we're pumping a lot of abrasives, mainly sand. And as we pump sand through a nozzle, it's going to wear the nozzle out. It's going to fleck pieces of the material off that nozzle over time. And that nozzle just gets bigger and bigger and bigger and bigger and bigger until all of a sudden it's no longer the size we wanted. It's 2 or 3 or 4 sizes bigger due to that sand rushing across the face of that surface, especially brass, and just etching it off, just peeling off little flecks of brass. Every time a sand particle hits that brass, it's going to erode a little bit of brass off the surface, which makes the hole a little bit bigger. And every time that happens, the hole gets a little bigger and a little bigger and a little bit. Pretty soon, that orifice is growing way beyond the designated size that you had originally put in the sprinkler. What happens when the hole gets bigger? More water comes out of it. All of a sudden, we've changed the total characteristic. Another thing that will generally happen is the pressure starts to drop in the system because of the fact that the orifices are getting too big. Then we start getting that donut effect on the sprinklers if it gets too severe. Now, plastic doesn't tend to wear near as rapidly, nor do the new style flow control nozzles have near the wear due to sand abrasion. And the flow control nozzle actually, and in the textbook there is a picture, a cutaway of a flow control nozzle, and in that nozzle there is a rubber insert. Now when you have pieces of sand hit rubber, the rubber just deflects the sand. It's resilient. It doesn't etch it out. It doesn't chew a piece of it off like it does with brass. Brass has no resilience. It's rigid, and when that sand particle hits it, it's going to chip into it. When it hits the rubber just deflects a little bit, and the sand particle deflects a little bit, and they just bounce off each other. Same with plastic. Plastic tends to have a little elasticity, so it will flex a little when it gets hit by that sand. It's not going to wear as fast as brass in general because it has a little give to it. And when the sand particles blast into those plastic nozzles, it'll flex a little bit and give a little and allow the sand to pass on down without taking a hunk of plastic with it. So it's critical that you keep monitoring that nozzle size. And a way to do that is if you have a line that's all consistent size. Say you're out here and you have a wheel line or a hand line, and they're all 11/64" nozzles. Well, you take a drill bit that's 11/64", insert it into the nozzle, it should just fit. So you can go down the line and check them, take the next size bigger, which would be 12/64", which would be what? 3/16". 3/16" bit, if it'll fit into the nozzle, you know that you've gotten a 64th wear on that nozzle. That might be too much. You might say, hey, that's unacceptable. I need to change my nozzles, if that's the case. So that's how you can go out in the field and actually test and see how big they really are. Just reading on the side of it, it says 11/64" doesn't mean that nozzle is going to be 11/64" in reality. It may have been eroded out. So test it with a drill bit and you'll find out if it's a round orifice, which the majority of the nozzles will be. Okay, water quality will have an effect on sprinklers, the wear on the sprinklers, Water quality also have an effect on how water enters the ground. So that will have a different slant to the performance. If you're putting real low quality water on that has a high deposit of certain materials, it's going to start sealing up the soil. It's going to get chemical reaction with that water when it hits the soils, and it's not going to allow the water to move into the soil as readily. Possibly. And if that's the case, you've affected sprinkler performance from the position of getting water into the ground. It's a kind of another angle.